Hello everybody, today we're going to talk about direct variation. Okay, so what's direct variation? Two quantities x and y show direct variation when y equals k times x, where k is a number and k is not equal to 0. Okay, the reason you don't want it equal to 0 is if I put 0 in here, 0 times x is 0, and you just get a horizontal line at 0. The number k is called the constant of proportionality. Essentially, this just means that this is the line that passes through the origin. The y-intercept is 0. So they make a lot of big deal out of direct variation, but all it is a line that goes through the origin. That's it. Any line. So like this line right here, that means that's direct variation because it goes through the origin right there. If it went through up here, not direct variation. But any line that goes through the origin is going to be direct variation. Okay? So there we go. Tell whether x and y show direct variation. Plot the points and draw the line. Okay, so 1, negative 2. So we're going to go 1 to the right and down 2. I can already tell that this, well, let's see. 0, 2. Right there, I can already tell this thing is not going to be a direct variation. 3, 2. It's not even a straight line. 4, 4. 4, 4. Okay, so this is not a straight line. Oh, this is 2, 0, not 0, 2. Okay, sorry, that's what I kept looking at this thinking that doesn't make any sense. 2, 0. There we go. Okay, so at least it's a straight line now, but even if I draw that line, it's not going to be direct variation because it doesn't go through the origin. Okay, so it is not direct variation because it doesn't go through the origin. Okay, so there we are. Okay, tell whether x and y show direct variation. Okay, so if we look at this one right here, the first thing I would do is put this into slope-intercept form, which remember is y equals mx plus b. So what I would do is I gotta get the y by itself. I would move the y over here. And I can tell this is not direct variation. Not direct variation. Because it doesn't go through the origin. And the reason I know it doesn't go through the origin is it's got a b over here that's something other than 0. So if this was just y equals 2x, yes, it would be direct variation. But it's not direct variation, again, because it doesn't go through the origin. Okay, so let's look at this one. Again, let's put this in slope-intercept form. So we're going to multiply both sides of this equation by 2. And that is going to go away, and I get y equals 2x. Okay, that is direct variation. I can tell just looking at it because it doesn't have a b. It doesn't have this b right here. It's just y equals some number times x. Okay, Luna the Math Cat wants to say hello to everybody. So there we are. Okay, so we've got direct variation here. So let's take a look at this one. Now you can tell just looking at this, This graph right here, it is direct variation because it goes through the origin. It's a nice straight line. So the table shows the area y in square feet that a robotic vacuum cleans in X minutes. Graph the data, tell whether X and Y are directly proportional. Okay, so let's see, cleans in X minutes. So in a half a minute, it cleans 8 square feet. In 1 minute, it cleans 16 square feet. This would be 1.5 minutes, it cleans 24 square feet. And in 2 minutes, it cleans 32 square feet. So that's all graphed right there for you. You can see. And the answer is yes. It's direct variation. Okay, it goes through the origin. So they are directly proportional. Okay. So there's another way you can tell they're directly proportional as well. If you take each one of these numbers and divide it by this number, and you always get the same number, that's going to be direct variation as well. So 8 divided by 1/2, that's the same thing as 8 times 2, that's 16. Okay, 16 divided by 1 is 16. 24 divided by 3/2 is the same thing as 24 times 2/3, which that cancels with this and leaves you with 8 times 2 is 16. And 32 divided by 2 is 16. So that would be another way to check and see, is that direct variation. It's a lot slower than being able to look at the graph, though, and say, oh, it passes through the origin, it's a nice straight line, it's direct variation. Okay, so you're going to get to do problems 1 through 33 odd in class next time. I look forward to seeing you. Have a great evening.